Good morning, my dear students. In this video clip, I want to discuss about the current electricity formulas. The formulas which are come across in the third chapter of your second PUC syllabus. That is current electricity in the physics subject. Okay. ಎಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸಲ್ಲಿ ಒಂದು ಮೈ ಕೈಂಡ್ ರಿಕ್ವೆಸ್ಟು ಏನಂದರೆ ನೀವು ನಮ್ಮ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಆಗಿರಿ. ಅಂದರೆ ಅಲ್ಲಿ ರೆಡ್ ಕಲರ್ ಸಬ್ಸ್ಕ್ರೈಬರ್ ಅಂತ ಬರುತ್ತೆ, ಪ್ರೆಸ್ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಬೆಲ್ ಬಟನ್ನ ಪ್ರೆಸ್ ಮಾಡಿ, ಅಂದರೆ ನಮ್ಮ ಚಾನಲ್ಗೆ ನೀವು ಸಬ್ಸ್ಕ್ರೈಬರ್ ಆಗ್ತೀರಾ. ಇದು ನಮ್ಮ ರಿಕ್ವೆಸ್ಟು ಎಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸಲ್ಲಿ. ಎಸ್, ನಾವು ಯೂಸುವಲಿ ಅಲ್ಲಿ ಸೆಕೆಂಡ್ ಇಯರ್ ಸಿಲೆಬಸ್ನಲ್ಲಿ ಪರ್ಟಿಕ್ಯುಲರ್ ಫಿಸಿಕ್ಸ್ ಸಬ್ಜೆಕ್ಟ್ನಲ್ಲಿ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಏನು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಅಂದರೆ ಬೇರೆ ಬೇರೆ ಚಾಪ್ಟರ್, ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ಮತ್ತು ಸೆಕೆಂಡ್ ಚಾಪ್ಟರ್. ಇಲ್ಲಿ ಫಸ್ಟ್ ಚಾಪ್ಟರ್ ನಾವು ತಗೊಂಡಾಗ ಅಲ್ಲಿ ಏನು ಬರುತ್ತಾ, ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ಸ್. ವಾಟ್ ಯು ಟೇಕ್ ಹಿಯರ್? ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ಸ್. ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ಸ್ನಲ್ಲಿ ಒಂದು ಚಾಪ್ಟರ್ ಆ್ಯಂಡ್ ಅನದರ್ ಚಾಪ್ಟರ್, ಸೆಕೆಂಡ್ ಚಾಪ್ಟರ್. In first chapter of the electrostatics, you have to study, that is the electric charge and electric field. Means what is the meaning of charge? What is the definition of charge? What it does? What happens? What is the force? What is the field? All these things in the first chapter. Now it is related to the charge at rest. ಅದು ಎದಕ್ಕೆ ಸಂಬಂಧಪಟ್ಟಿದ್ದು? The charge is at rest. That's first second chapter. It is particularly for charge at rest. And then second chapter, now you study the one very important point, that is said to be electric potential, and one more important point, capacitors. And before going to the capacitors, that is said to be capacitance. SI unit is farad. SI unit of electric potential is volt. SI unit of charge is coulomb. SI unit of electric field is Newton per coulomb. Okay. Now first and second chapter in the electrostatics, it is deals with the study of electric charge at rest. Now whatever thing you have to study in the electrostatics, charge is at rest. Therefore, the electrostatics is also nothing but what you say, that is static electricity. Static electricity, electrostatics, it deals with the study of electric charges at rest. Okay, field antave, force antave, potential antave, capacitor, capacitance, all these things you have to study. Okay, fine. Now we come to the third chapter, that is current electricity. Now current electricity, it is a branch of electricity. Now it deals with the study of electric charge in motion. When the charge is in motion, at that time I have to write that it is current electricity. It is a branch of electricity. It deals with the study of electric charges in motion inside the conductor. Suppose the charges are moving inside the conductor. Now the charge carriers, free charge carriers, inside the conductors, they are the electrons. And few solutions of conductor, they are said to be radicals, molecules, ions. They are the charge carriers in a gas and the liquid. Conscious point. Now we come to the point, current electricity. In that current electricity, in this video clip, I want to discuss about whatever the formulas, equations arises, come across in the current electricity. That I will take. Now first one, whatever the charge flow, it is Q is equal to N/V. Charge is equal to N/V. Number of electrons are flowing inside the conductor, and then you say the current. Charge carriers are you take the electrons in a solid conductor. Okay. Now you come to the next one. Next, there is a current. Next equation is basically current. Current, that is I is equal to Q divided by P. This is equal to N into E divided by P. What is N here? Number of electrons. Suppose you want to take this is capital letter N. No problem. Capital letter N. N is basically number of electrons. Number of electrons flow inside the conductor across cross section area. Current I is equal to Q divided by P. Suppose Q1 is positive and Q2 is also positive. Q1, Q2 both are positive. They are in the same direction. In the same direction. At that time, the formula is said to be Q1, that is minus Q2 divided by T. Q1 minus Q2 divided by T. ಇವಾಗ ಎರಡೇ ಏನು ಬರ್ತದ ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಇರುತ್ತೆ. Q1 is positive and Q2 is said to be negative in the opposite direction. At that time, I is equal to Q1 plus Q2 divided by Q1. Q1 plus Q2 divided by Q2. They are in the and they are opposite. Now you measure this current. This current is said to be electric current. Current ಅಂತ ತಕ್ಷಣ ಬೇರೆ ಬೇರೆ ಕರೆಂಟ್ ಬರುತ್ತೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಇಲ್ಲಿ ನಾವು ಹೇಳ್ತಾ ಇರೋದು ವಾಟರ್ ಕರೆಂಟ್ ಬರುತ್ತೆ, ಸಿ ಕರೆಂಟ್ ಬರುತ್ತೆ, ಈ ಥರ ಬೇರೆ ಬೇರೆ ಕರೆಂಟ್ ಬರುತ್ತೆ. ಬಟ್ here the flow of electric charges now, therefore you say this is electric current. Yes, now here important point is to study the Ohm's law. Ohm's law, the potential difference across cross-section electric conductor, or you say the current, the steady current flow through the conductor, steady current flow through the conductor is directly proportional to potential difference across ends of the conductor, provided temperature and other physical conditions are remains constant. The Ohm's law. Yes, P is equal to, this is basically IR. P is equal to IR. This is Ohm's law equation. I is equal to P divided by R, and R is equal to what you say to me V. What is V here? Potential difference across the ends of the conductor. What is I? Strength of the current. What is R here? R is nothing but electrical resistance. What is electrical resistance? How do you define? The opposition offered by the conductor to the flow of electric current is called electrical resistance. Once again I repeat, the opposition offered by the conductor to the flow of electric current is called electrical resistance. Sometimes few students have to write that is the opposition offered by the conductor to the flow of electric charges. That is also okay, but correct definition is you take the opposition of the electric current, provided temperature and other physical conditions are remains constant. What is the SI unit of resistance? SI unit of resistance is ohm. Now R is measured in, P is measured in volt here, and I is measured in ampere. A ampere, A, and R is measured in ohm. Ohm Greek letter like this, and this is like this, called capital letter V. Now charge is measured in here, coulomb, C. It is represented by C. Now this is the Ohm's law, and resistance depends upon what are the factors. If the factors is resistance depends on what are the factors. R is proportional to L, and R is inversely proportional to cross section area. Resistance of any conductor is directly proportional to its length, and it's inversely proportional to, that is the cross section area. Then R is proportional to L by A. Then R is equal to rho into L by A. Now rho is said to be resistivity. Rho naventalli resistivity anta ಹೇಳ್ತಾರೆ. Resistivity of the material of the any wire or certain material. Now the SI is ohm meter. Now resistivity is equal to A divided by L into R. ಏನಂತ ನೀವು ರೌಂಡ್ ವೈರ್ ತಗೊಂಡ್ರೆ pi r square R divided by L. Diameter ಬರೆದ್ರೆ pi d square R divided by pi d square R divided by 4L. So depending upon what type of wire is also used. But square wire is used, area is A into A square is what? Suppose rectangular you take and width into breadth A into B, area becomes A into B is what? Now we come to the point, fifth one, that is said to be current density. Fifth one, current density. Current density, how you define that is the current density? The current per unit area, current flow inside the conductor per unit area, this is called current density. Current density is J, I divided by A, SI in this, that is ampere per meter square. But it is a vector here, this is a vector quantity. Current density is vector. Therefore, you have to write in vector form, you have to write I divided by A. That time you got vector A. Okay. Now this is I divided by A. Therefore, current density that is equal to sigma into vector B. It is transferred to this current. That is the area. The vector transferred to that area. The SI of this is ampere per meter square. And sixth one, drift velocity. How the electrons or charge carriers inside the conductor, how they flow. According to microscopic theory, these electrons or whatever the charged particles, they collide one and another with the atoms and the electron. Due to the successive collision of the electrons, then electrons are drift inside the conductor with a certain velocity. Okay, then average velocity with which the electrons are drift inside the conductor, this is called drift velocity. Average velocity. ಯಾಕೆ ಅವರೇಜ್ ತೋರಿದ್ರು? ಕೆಲವೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಒಂದಿಷ್ಟು ವೆಲಾಸಿಟಿ ಒಳಗೆ ಹೋಗ್ತವೆ, ಕೆಲವೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಹೆಚ್ಚು, ಕೆಲವೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಕಡಿಮೆ. ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ? ಎವರೇಜ್ ವೆಲಾಸಿಟಿ ಕೊಡ್ತೀವಿ. ದ ಡ್ರಿಫ್ಟ್ ವೆಲಾಸಿಟಿ ಇನ್ಸೈಡ್ ದಿ ಕಂಡಕ್ಟರ್ that you have to write PD is equal to minus B into E divided by, now this is M into 2. Yes. Here I is the current flow to the conductor, A is the cross section area of the conductor. Now here drift velocity, E charge of the electron. Capital letter E electric field. M mass of the electron. Tau is relaxation time. What is relaxation time? The average time interval between the two successive collision of the electrons inside the conductor. This is called relaxation time. Once the electrons are charge carriers, they drift to one, they collide one and another, and the drift takes place. At that time, average time interval between the two successive collision of the electrons inside the conductor, that is called drift velocity. It is measured in meter per second. It is a relaxation time. This is mass of the electron. E is the electric field which is exists inside the conductor. Then E is the charge of the electron. M is the mass of the electron. It is measured in meter per second. Okay. Now this is the seventh one. Is the mobility. Mobility of the charge carriers. Now here mobility of the electrons you have to take. Mobility. The mobility is defined as drift velocity per unit electric field. ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನು ಕ್ಲಿಯರ್ ಆಗಿ ತಿಳ್ಕೋಬೇಕು. ನಾವು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಯಾವಾಗ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ ಕಂಡಕ್ಟರ್ಗೆ, ಇಟ್ ಮೀನ್ಸ್ ವೆನ್ ಯು ಅಪ್ಲೈ ದ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅಕ್ರಾಸ್ ದಿ ಹೆಡ್ಸ್ ಆಫ್ ದಿ ಕಂಡಕ್ಟರ್, ಡೆಫಿನೆಟ್ಲಿ there is a electric field inside the conductor. Once electric field inside the conductor and the electric force act on a charge carriers inside the conductor. Once force act on a charge carriers inside the conductor, then the charge carriers are drift inside the conductor, and you got the current, you got the drift velocity, all these things. Once potential is there, definitely in automatically electric field. Once electric field is there, electric force act. One electric force act charge carries drift. Once our charge carries drift automatically current develop ಆಗುತ್ತೆ. ಈ ಪಾಯಿಂಟ್ ಭಾಳ ತಿಳ್ಕೋಬೇಕು. ಅವಾಗ ಕರೆಂಟ್ ಏನಾಗುತ್ತೆ inside the conductor, the current in terms of PD means drift velocity. in terms of drift velocity. Yes, what is that current? Yes, I is equal to NA E dV. This is once again, N is not a number of electrons. For example, you take the copper, aluminum, whatever you take the good conductors. N here is there, electron density. What is the meaning of electron density? Number of electrons per unit volume of the conductor. This is called electron density. Electron density is different for different materials. All conductor electron density one. For example, copper, it is having certain electron density, and aluminum, it got another electron density. Electron density is different for different metals or different energy. N here, electron density. Therefore, capital letter N you have to take number of electrons, number of charge carriers. A, cross section area. E, charge of the electron. PD, drift velocity. This is point. Now, next formula, that is said to be conductivity. Here you want the resistivity. Now you have to take the conductivity. Ninth one, that is said to be conductivity. Conductivity. This is the conductivity. Sigma. Sigma is said to be conductivity. That sigma is equal to reciprocal of the resistivity. That resistivity N is square conductivity tau divided by conductivity is equal to N is square tau divided by N is electron density. Once again, N means electron density, number of electrons per unit. E charge of the electron, tau relaxation time. M is mass of the electron. Now, resistivity. Resistivity is a reciprocal of this one. N is square tau, reciprocal of that conductivity. Now, conductivity is reciprocal of the resistivity. Reciprocal of the conductivity is said to be resistivity. Now, SI of conductivity is what you say, that is Simon per meter. This is unit is ohm. And resistance and conductance. Conductance is reciprocal of the resistance. SI of conductance is Simon. But SI of conductivity is Simon per meter. Or you said to be mho per meter. Is the SI of what you say? That is conductivity. Yes. Resistance at certain temperature. Resistance at certain temperature. Certain temperature. Yes. Now, one of the point, very important point, that is how the resistance is varies. How the resistance is varies. What are the factors? The resistance is mainly depending upon nature of the material, one point. And resistance is depends on dimension of the material. That resistance dimension of the material depends length, area, and one more important point, resistance of the material is very, very important. It is depending upon temperature. Now, the temperature of the material is varies, definitely resistance is varies. How it varies? Depending upon nature of the material. For example, you take that is a good conductor. But in the case of good conductor, resistance is one increases with increase in the temperature. Resistance of good conductor increase ಆಗ್ತಾ ಹೋಗುತ್ತೆ ಯಾವಾಗ ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಬಟ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಸೆಮಿಕಂಡಕ್ಟರ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ಡಿಕ್ರೀಸಸ್ ವಿತ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ದ ಟೆಂಪರೇಚರ್. ನಾ ಈ ವಿಡಿಯೋ ಕ್ಲಿಪ್ನಲ್ಲಿ ಓನ್ಲಿ ಫಾರ್ಮುಲಾ ಮಾತ್ರ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಇದಕ್ಕಿಂತ ಪ್ರಿವಿಯಸ್ ವಿಡಿಯೋ ಕ್ಲಿಪ್ನೊಳಗೆ ಇವೆಲ್ಲ ಪಾಯಿಂಟ್ಸನ್ನು ನಾನು ಏನು ಮಾಡಿದ್ದೀನಿ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಬಂದಿದ್ದೀನಿ. ಎಸ್, ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಟ್ ಸರ್ಟನ್ ಟೆಂಪರೇಚರ್, ದಿಸ್ ಈಸ್ ಸೆಡ್ ಬೈ ಆರ್ ಟಿ. ಆರ್ ಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ನಾಟ್ ಇಂಟು ಬ್ರಾಕೆಟ್ 1 ಪ್ಲಸ್ ಆಲ್ಫಾ ಟಿ ಮೈನಸ್ ಟಿ ನಾಟ್. ಯಾವಾಗಿದು ಟೆಂಪರೇಚರ್ ನಾವು ಎದುರು ತಗೊಂಡಾಗ ಅಬ್ಸಲ್ಯೂಟ್ ಸ್ಕೇಲ್ನ ತಗೊಂಡ್ರೆ, ಟೆಂಪರೇಚರ್ ಅಬ್ಸಲ್ಯೂಟ್ ಸ್ಕೇಲ್ನ ತಗೊಂಡ್ರೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಈಗ ಬರೀತೀವಿ ಆರ್ ಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಆರ್ ನಾಟ್ ಪ್ಲಸ್ ಆರ್ ನಾಟ್ ಇಂಟು ಆಲ್ಫಾ ಟಿ ಮೈನಸ್ ಟಿ ನಾಟ್ ಬರೀತೀವಿ. ಇದನ್ನ ನೀವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಆಲ್ಫಾ ಬರೆದ ಆರ್ ಟಿ ಮೈನಸ್ ಆರ್ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್, ದಟ್ ಈಸ್ ವಾಟ್ ಆರ್ ನಾಟ್ ಇಂಟು ಬ್ರಾಕೆಟ್ minus t minus t naught. R naught into bracket t minus t naught. Now here t is measured in Kelvin. Suppose it is measured in Celsius, RT is equal to R naught T ಬರ್ತದೆ 1 plus alpha T ಬರುತ್ತೆ. Now that is RT is equal to R naught plus R naught alpha T ಬರುತ್ತೆ. ಅವಾಗ alpha ಏನು ಬರುತ್ತೆ RT minus R naught divided by R naught T ಬರುತ್ತೆ. ಈ ಫಾರ್ಮುಲಾದು ಟೆಂಪರೇಚರ್ ಕೆಲ್ವಿನ್ ತಗೊಂಡಾಗ ಈ ಫಾರ್ಮುಲಾದ ಟೆಂಪರೇಚರ್ ಸೆಲ್ಸಿಯಸ್ನಾಗ ತಗೊಂಡಾಗ ನಾವೇನು ಮಾಡ್ತೀವಿ ಇವುಗಳನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಯೂನಿಟ್ 4 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಆರ್ ಪರ್ ಎಸ್ ಆಯಿತು ಅಂದರೆ ಪರ್ ಕೆಲ್ವಿನ್ ಬರುತ್ತೆ. ರೆಸಿಸ್ಟರ್ ಆಲ್ಫಾ in terms of R1 and R2 resistance, our alpha is equal to inverter, that is R1 into minus plus R2, sorry, this is R2 minus R1 divided by R1 T2 plus R2 T1 per. This is in terms of two resistances. Here temperature should be measured in Celsius only. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ ಟೆಂಪರೇಚರ್ ಮಾತ್ರ ಸೆಲ್ಸಿಯಸ್ ಕೆಲ್ವಿನ್ಗ ತಗೊಳ್ಬೇಕು. ಎಸ್, what is alpha here? Alpha is said to be temperature coefficient of resistance of the material. Once again repeat, alpha is nothing but temperature coefficient of resistance of the material. Alpha of temperature coefficient of the resistance of the material ಅಂತವೆ. Now the different materials they have different temperature coefficients of the resistance. ಬೇರೆ ಬೇರೆ ಮೆಟೀರಿಯಲ್ಗೆ ಬೇರೆ ಬೇರೆ ಟೆಂಪರೇಚರ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇರುತ್ತೆ. ಎಲ್ಲವೂ ಒಂದೇ ಇರಲ್ಲ, ಕೆಲವೊಂದು ಲೋ ಇರುತ್ತೆ, ಕೆಲವೊಂದು ಹೈ ಇರುತ್ತೆ. ಒನ್ ಮೋರ್ ಪಾಯಿಂಟ್, ಇನ್ ಅ ಫ್ಯೂ ಮಟೀರಿಯಲ್ಸ್ ಆಲ್ಫಾ ಇಸ್ ಪಾಸಿಟಿವ್, ಇನ್ ಫ್ಯೂ ಮಟೀರಿಯಲ್ ಆಲ್ಫಾ ಇಸ್ ನೆಗೆಟಿವ್. ಕೆಲವೊಂದು ಮೆಟೀರಿಯಲ್ ಆಲ್ಫಾ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ, ಇನ್ನು ಕೆಲವೊಂದು ಮೆಟೀರಿಯಲ್ಗೆ ಆಲ್ಫಾ ನೆಗೆಟಿವ್ ಬರುತ್ತೆ. When you got positive, if the temperature of the material is go on increases, okay, then resistance is also increases. At that time alpha should be you got positive. Such type of materials are said to be PTC materials. PTC is nothing but positive temperature coefficient materials. In few materials, for example semiconductors, that is the resistance is go on decreases with increase in the temperature. Such type of materials they are said to be NTC material, means negative temperature coefficient materials. NTC materials ಅಂತ ಹೇಳ್ತಾರೆ. ಅದರೊಳಗೆ ಏನು ಬರ್ತದೆ ಆಲ್ಫಾ ನೆಗೆಟಿವ್ ಅಂತ ಬರುತ್ತೆ. ಯಾಕೆ ರೆಸಿಸ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತೆ ಹೋಗುತ್ತೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ಟೆಂಪರೇಚರ್ coefficient, resistance at a certain temperature, all these things. And 11th one, what is it? It's the power in current electricity. You have to write P is equal to P into I. R is another formula, P square by R. Another formula, I square R P by. ಮೂರು ಫಾರ್ಮುಲಾ ಏನು ತೋರಿಸ್ತದೆ? ಪವರ್ ತೋರಿಸ್ತದೆ. ಸರಿ, ವರ್ಕ್ ಡನ್. Now the work done and heat is equal here. Work done, delta W is equal to P into I into delta T. Now here heat produced is also P into I into T. ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತಾ ಅಷ್ಟು ಹೀಟ್ ಜನರೇಟ್ ಆಗುತ್ತೆ. ಎಲ್ಲರಲ್ಲಿ ಕಾಯಿಲ್ನಲ್ಲಿ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಆಗುತ್ತಾ ಅಷ್ಟು ಏನಾಗುತ್ತಾ ಹೀಟ್ ಜನರೇಟ್ ಆಗುತ್ತೆ. ವರ್ಕ್ ಡನ್ ಹೀಟ್ ಆಲ್ಮೋಸ್ಟ್ ಐಡಿಯಲ್ ಕಂಡೀಷನ್ ಒಳಗೆ ಈಕ್ವಲ್ ಅಂತ ತಗೊಳ್ತೀವಿ. ದೇ ಆರ್ ಮೆಸರ್ಡ್ ಇನ್ ವಾಟ್ ಇಸ್ ಸೆಡ್ ಟು ಬಿ ಜೌಲ್. ವಾಟ್ ಎವರ್ ದ ವರ್ಕ್ ಡನ್ ಆರ್ ಯು ಸೆಡ್ ಟು ಬಿ ಹೀಟ್ ಜನರೇಟ್, it is mainly depending upon what are the factors, whatever the applied voltage, whatever the current flow through the coil, and the time for which current flow through the coil. These two factors ಮೇಲೆ depend ಇರುತ್ತೆ, power and heat generate. Then next formula we go to this one, series combination of resistors. Series combination of resistors. Two resistors RS is equal to R1 plus R2. R1 and R2 are the resistance of the individual resistors. Then RS is the effective resistance of the series combination of two resistors. If more than two resistors have to connect at that time, R1 plus R2 plus R3 and the 2 points are very important here in the series combination. Current flow through each resistor is same. Then potential difference across the resistor is defined. The net potential difference across the series combination is equal to sum of the potential differences across individual resistors. ಈಗ ಇಲ್ಲಿ parallel combination ಬರುತ್ತೆ. Parallel combination. ನಾವು parallel combination of resistors ಬಂದು 1 upon RP is equal to 1 upon R1 plus 1 upon R2. ಏನು RP ಬೇಕು ಅಂದ್ರೆ you got R1 into R2 divided by R1 plus R2 but ಇದು RP is effective resistance of the parallel combination of resistors. Two resistors means two resistors, three resistors, or three resistors. To take the number of resistors, in general you have to write more than three resistors, two resistors, or 1 upon RP is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. This is series and parallel combination of the resistors and effective resistance of, that is what you say, that is said to be parallel combination. ಆಮೇಲೆ ಇಲ್ಲಿಂದ ನೆಕ್ಸ್ಟ್ ಹೋದಾಗ ಅಲ್ಲಿ ಏನು ಬರುತ್ತೆ, ಸೆಲ್ಸ್ ಬರುತ್ತೆ. ಸೆಲ್ ಅಂದರೆ ಏನು? ಇಟ್ ಇಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಸೋರ್ಸ್ ಇನ್ ದ ಸರ್ಕ್ಯೂಟ್. ವಿ ಸಪ್ಲೈ ದ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ ಕಂಟಿನ್ಯೂಸ್ಲಿ. ಇಟ್ ಈಸ್ ಯೂಸ್ ಟು ಡ್ರೈವ್ ದ ಚಾರ್ಜ್. ಹೀಗೆಲ್ಲ ಬರ್ತವೆ. EMF ಆಫ್ ದಿ ಸೆಲ್, electromotive force. SR of electromotive force is EMF is volt. Once you connect in this resistance across the cell, once you close the plug key, close the circuit. You got the finite resistance, external resistance. Now open the key. This is open circuit. At that time, resistance across the cell is infinite. At that time, it is infinite, finite and infinite. Yes. Now current in simple circuit. At that time, current in simple circuit. Current in simple circuit is very important. That is I is equal to V divided by R plus R. Now, if R is equal to 0, this is said to be short circuit. Short circuit. The maximum current is drawn here. V divided by R. This is one of the R is maximum. Now, if R equal to 0, this is said to be ideal circuit. This is the ideal circuit. Now, I is equal to, at that time, I is equal to V divided by R. At that time, the cell is said to be ideal cell. Once it is ideal cell, now terminal potential difference. P is equal to E minus IR. This is another terminal potential difference expression. P is equal to E minus IR. What is E? EMF of the cell. What is I? Current flow in the simple circuit. What is small letter R? Internal resistance of the cell. You take the cell, electrical energy source. Definitely that having certain EMF of the cell. Then that is having internal resistance. EMF of the cell is measured in volt. Then internal resistance is measured in ohm only. It is very small. Depending upon whatever the preparation of the cell, kind of the cell. Okay. Now this is the terminal potential difference. For this one, the value of this R is equal to 0. Now V is equal to. It means circuit is said to be, what type of circuit is said to be? That is open circuit. Terminal potential difference are said to be defined the EMF of the cell. The EMF of the cell is defined as the terminal potential difference across two terminals of the cells in the circuit if the circuit is open circuit, like that. P is equal to E. If it is ideal circuit. Yes. Now, terminal potential difference is also taken according to this one. Now this one, P is equal to I into R. This is also is equal to E into R divided by R plus 1. This is also expression for terminal potential difference. If R is equal to infinity, this is said to be open circuit. R is said to be finite. This is said to be closed circuit. Like that. Okay. Now, series combination of the two cells. You come to the point. What in one? Series combination of two cells two cells. Here E equivalent is equal to E1 plus E2 and R equivalent is equal to, that is R1 plus R2. Sorry, 1 minute.